Hello. This is the first video we are going to do with the CPU simulator project. So if you have not watched the video of the introduction of this video, you can watch this in either here or here. I'm gonna try to learn how to put links in the YouTube video. So I'm gonna start imagining you know what is the project about. So let's start. I'm gonna create a zig binary, of course, first, and let's go into main file. So I have nothing to do with these, so let's just start with our CPU. So our CPU is going to be a struct, and it's going to have also a memory, which is also a struct, and our CPU is going to have 16 registers. So registers are a 16 len array that has some data in it, and the data in each register can be either it can be two things. It can be a reference to some place in memory, in heap, basically in heap of the program, or it can also be a reference to a constant that is defined in the data section of our binary, right? So we are going to have this as so it's going to be a data, and let's just call this register. So each register, it's going to be a union of an enum, which we will define later, and this enum is basically our data types. So data types is an enum that we have basically reference, and which is a memory reference, and also a constant, which is defined in our binary. With this, so our reference is going to be a U64, right? Our CPU is a 64-bit, so we are going to imagine that we have also a 64-bit integer, and also the constant is a bit tricky because in theory we could store anything in our CPU code. So I'm gonna imagine that this constant is also a U64 for now. We probably need to change this later. This is data types, this is register. We come down, so this is our CPU basically. Pubfn init returns a CPU, and this just for now returns an empty struct. Okay, our memory on the other hand is a stack based memory. So there's a stack, and we can basically implement a stack using arrays, but let's have a separate data structure for this. So stack is also struct. So there's data in it, which is so how much our stack size is going to be, how much a CPU stack is. Let's take a look. So CPU, for example, x86, where is this x86 CPU stack size? Actually, I think a stack is in RAM, right? You know what, let's just continue. So our stack size, so I'm gonna make a stack a generic function, so function stack that gets a count time size, which is u64, returns as type size, also u64s. Basically, we also have some functions, so pop from stack returns a u64, so it's going to say self.data.len for an array, I necessarily don't know what is, so it's a stack, so everything is at, so if we want to use this as a stack, there's a cheat I can do using array list, but let's think about stack. So if I want to stack using array, let's see, pop, check whether stack is empty. If it's empty, if not empty, delete a stack.top. Yes, actually we can do that. Since it's an array, we are already allocating data, right? So we are going to basically put stuff from the last position. So for pop, we are going to let's have a top value, which is a u8, and we are going to say data self.data.top equals -1, minus equals 1, like this. Can we do this? Okay, self.data. Return self.top, not data. Self.top, return the value. It's not important because the next time we are doing a push, which is given a value, we are going to do is self.top +1 return a self.data top equals a value. What did I do wrong? We don't have any return value in here. Okay, void. Use of undeclared self. So we have a simple stack implementation. We also now have a memory. So our memory has a stack, which is a stack of 64. We can make this a smaller stack, but who cares? Let's make this 60. We also have a heap. So what is a heap and how it looks and acts? Let's see. Let's have this open. Heap memory. So what is a heap memory? Let's see. So this is okay. What is heap memory? Young generation, old generation. Example. I'm thinking how to model the heap inside this CPU we have. So if heap, so if we imagine heap as part of RAM, and we know that each bit in a register in a CPU points to a byte in RAM, so what we can do is to have an array of bytes, 8-bit integers, basically 8-bit booleans, or so can I do this for heap? So can I say a list for let's say a list of 8-bit unsigned integers, basically each one holds a value, right? Also, let's make memory generic. So return struct this fn memory comp time stack size u8 comp time heap size u8 returns a type. So this is stack size, this is heap size. So we got our memory as well. This memory has some other functionalities that we didn't implement. So for the stack we have this, but there are going to be methods on this as well, but we didn't implement these as well. So let's actually talk about instructions of our CPU. So an instruction in our CPU is basically, if we open up our readme file, you see that each instruction has an operator or opcode, a reference for output, and 2 references. So we can make this static and really fast. So what I'm going to do is I'm going to store an opcode which is u8. How many instructions can we have if we have u8? I think 256, I think. I'm not sure. I'm not good with this stuff. And we are going to have basically an out, which is also u8. We are going to have arg1, which is a u8. These are not u8s. So wait, these are going to be data types. So instructions are either instruction arguments are either references to registers or constant values, right? So I'm gonna have the same thing, and I'm actually gonna put this in top. And arg1 is going to be a register, right? So we know Actually, I'm gonna rename this register thing into ref. Okay. Ref. arg2 is going to be also a ref. H, it's not going to be a ref actually. I'm wrong, because in an instruction we can only point to a register, which we have 16 of them, or a constant value. So it's going to be different actually. These are not the same thing. So let's put these back in here and format this. These are going to be constant, and let's just call this register again. Register. Constant ref. A ref can be a union of an enum. Can we do this? No. Sorry, no. Ref type, which is this. A ref is either a constant or a register. Ref type. If it's a const, it's going to be string actually. So any value basically. If we put a string, we actually can support basically anywhere, because in an instruction in this level we can only have integers or strings. So by having strings we can support both. We also have a register, which is a U8 is enough, because this is the number of the register. So we have 16 registers, so U8 is enough for us. And yes, I think this is actually good. Yes, I'm really worried about this part. I'm really worried about the addressing and stuff. But so each register in here either has a heap reference or a constant. This is not a constant actually. This is called value. Value in register, like an int. There's also another way. You can have a heap reference. We also can have a basically code reference. Reference to data part of binary. This will be not used right now. We are going to just support this for now, right? So it's going to be heap reference, and don't have that, and only value. So we are going to just support value types in registers to make everything simple and workable. We are going to have these later. So I just want to make something that works for start. So let's have some constants. So public function instruction set returns an instruction. So a set basically gets a a set basically gets a reference to a register. So register reference, which is U8, and also a value, which is a U64. U64. Return so what is going to be the opcode for our operations? I'm gonna have I actually want to do is I'm gonna do the constant opcodes, which is an enum, and I'm gonna make this CPU.opcodes set returns opcode is dot set, and the out, there's no out, you know, so set is an instruction that only takes that only feels the out ref. So this is the register ref, and the arg1 is okay. Which one should I use? And arg1 is okay. I'm gonna call this value, and each value, for now we don't support strings. Unsigned int 64, and the arg1 is val. Did I do something wrong? I should use this. Yes, I always you know, mix this in my mind. So I have the set instruction. Okay, I also do add instruction. So add instruction needs outref, which is U8, needs arg1. Arg1 is tricky because it's actually a ref itself. Arg2 is also a ref. Instant. Also in here, set can be ref1 and ref2, because you can do this. So let's do outref and inref, and this is just a ref, and this is not a ref actually, this is just a register, so it's a U8. This is outref, and this is, these are our refs, and this is just a reg. Let's just call these reg. So this is register, out register. There's a problem because I'm not no, there's no problem because out is always a register. So out is always a register number, so it's okay. In ref. Okay, we don't have these, so return. So our opcode is going to be .add, which we don't have in here, so let's add. The out is going to be out register. The arg1, arg2, arg2. There's also a print or display function for that which is defined for a list of instructions that that just prints these for each instruction. What we do is instruction I think like this. So we do opcode out arg1 arg2 index inst dot opcode inst dot out inst dot arg1 inst dot arg2. Do this so we can display these. And actually let's start with this. So let's go in CPU. In here in our main, let's do instruction.display. Constant instructions is a list of instructions. So I do instruction.set. The out register is going to be 1 and actually 0. So the 0 register, I'm gonna set the value, right, a reference. So inst.ref dot inst.ref let's can do this dot value, for example 10. Register 1 is also 10. We can finally do add, put the result in register 2. We need 2 refs. So the first one is going to be dot register 0 register 1. Hopefully this works. Sure it's not. So I expected the type slice of instructions. I found a constant. How we can fix this? Missing field arg2 in main line 17. Where are you? So when I'm doing arg2, the default can be undefined. The default of this can be undefined. Can we do this? Expected type slice of instructions found constant pointer to this. So can we do, if I make this a var, will this fix this? Nice, it actually a bit worked. So let's just do the \n in here so we can see these. So 0 instruction 0, opcode set, register 0, value 10. Oh, this is the gibberish. 1 and final 2. So let's actually do run. Why not? So it's like display gets instructions, which is a slice of instruction, returns nothing. It's a void. So for each instruction in our for each instruction, what we do is we switch on instruction.opcode. It's set. What we do, if it's set, what we do is we set a register. Can we do this? So what we do is we need self here, because do we have self defined? No. Constant self constant self equals this. Oh, sorry. Okay. Self that registers. So the instruction out is register equals ends.arg1. Basically, this is what set does. We also have add. What add does is self that registers instruction out register equals instruction dot. So we need to do some things. Constant arg1 is a switch. So switch on what? Can we do switch just like this? No. Can we do switch? Is there switch expressions in Zeek? I want switch expression. Yes, there is, which is cool. So instruction dot arg1 dot if how we can switch on exactly this tagged unions. So we have point, which is a struct, item, which is a tagged union. Oh, we can do this enum union enum, right? So we don't need actually these, which can be just enum. We don't need this. Like this we don't need. So on A, if it's an item.a or E, we do this. Okay. So the instruction argument, if it's where is this? Ref. If it's instruction ref dot, okay. So if it's instruction ref dot register, what we do is we basically return the value inside that register. So registers get that value. Fetch. If it's a value, we just return that. We have the same code for argument 2. And finally, we can evaluate this and put this inside register output. So we run this again, we get the opcode. The problem with this undefined thing, so what does undefined do exactly in Zig? Undefined, exactly. So what does undefined do? Undefined leave variable uninitialized. So yeah, let's just have these. If can we compare a value to undefined? I don't know. I don't want to print this. These are undefined. These are undefined. So yeah, let's actually run. So what I'm gonna do is I'm gonna create a CPU, which is CPU dot init creates a CPU. I'm gonna do run for instructions, and run is going to put the result inside register number. So add inside register number 2. So after that, what I'm going to do is to actually, let's add a kind of, display function to CPU. So register state is going to also do void, also doing some kind of a print inside these registers. So for each it's going to be also in self, for self.registers reg std. There is print, I think. Do we have this? No. std debug print reg. So each register is value index index. So if we get our state, registers state, after this, we should be able to see the result. We don't, because run can fail for some reason. Missing field registers and no member named outreg inside register inst. So we do have these 51. Let's go 51. So in here we don't have registers, so I'm gonna just do undefined. Can we use this as undefined? Yes. And also in 64, actually no. So how to allocate an array? Yes, this is okay actually. So no member name outreg in line 64. Self.registers inst outreg. There is nothing called this. This is out. Yes. What was the bug? Out. Cannot assign to a constant. Is registers a constant? 64? How is a register a constant? I don't get it. What? How? How a register is a constant? I don't get it. What about now? expected type register found ref. Okay, because instruction argument is a ref and the register is register, so we need to convert this. So a ref for now can also only be a value. So when I'm doing set, so this is important. Okay, so the value inside this arg1 is either instruction ref register. If it's a register, capture it and return the value inside that register. If it's a value, just return that. These will no, because if it's a register, okay, if it's a register, so value inside of that register, and okay, so what is a register? It only has values. So CPU or self dot register dot value equals this. It's a bit hard to read. Expected type U64 found register value. Actually, we don't need this like this. This could be simpler. So this can become a CPU.register dot value okay. Incompatible types register and U64. No, it's not, because I'm doing both. Type register, type value. Oh, in here. So yes, okay, so these should be value. I should get the value for both. Okay, no member name outrage out. Expected type register found U64. Yes, because in here we should do CPU dot. Can I do this? Yes. Holy shit, we did it. We now have a CPU that we can pass some instructions, has registers, and can evaluate stuff. So nice, so nice. I really like this. Really like this. So register, everything cool. So you see that our 0 register, so these are our instructions, these 3. So first 2 are sets, and the third one is an add, which puts the result of the add inside register number 2. So the argument 1 is register 0, argument 2 is register 1, and it will add 2, and it will put the result in here. So actually we can change this a bit. It's really simple. So I can just change this to 1. Now the 2 should be also gibberish and 1 should be 20. If we run, yes, you see this is working. Yeah, I really like when your program, I mean, it's really a nice feeling that your program is working. It's really nice Really nice. So let me just do for now, let's just remove this. So commit first working version CPU. So set add instructions. Also we added registers, memory, stack, heap. We didn't use them for now. I mean, we can have most of the things with these registers. Okay, I'm really happy with this. I'm really happy. So this is actually our work is now much simpler because we have this scaffolding. We can implement almost all mathematical instructions simply, and we have time, so let's at least do the subtract. So the subtract is also a opcode in our CPU instruction set. So a subtract is exactly like this. And completely, I mean, it's basically copy paste. That is it. We also have division. Actually, you know what? Let's just copy paste everything. Div. Okay, and multiply. And other things we had set, add, subtract, multiply, div, power. So let's add power. Do we have this operator in Zig? Probably have. So let's add these as well. So subtract, div, multiply, power. Cool. So we can have so many things in here now. So we can have also an instruction to do also similar to add. So we had add, we have subtract, we have div, we have multiply, and there's this power, which is power. So in here I can do instruction.pow. So gets an output register, put this in two inputs are register number. So I'm gonna do register number 0, which is 10, and the power is going to be actually using a value, constant value of times 3. So it will be 1000. Okay, so there's a problem. Where? Okay, here. So if I run my code again, Zig Okay. Is the power operator the basically the hat operator in here? Okay. No. So the instruction number 2 is the add. Instruction number 3 is put the hat high power. Yes. So we should use std.math.pow. So x raised to the power of y. So is this a generic type? Yes. I think I'm U64. So arg1 and arg2. Run. I think we did something wrong. So it shouldn't be this much, right? Because 10 power 3 is going to be std.math.power U64 10 3. What would happen? Expression value is ignored, right? So std debug print okay. Thousand. Okay, so this is correct behavior. So I'm saying that put in output register 2. So why the power is not correct? std debug print arg1 arg2 arg1 arg2. Ten and 10? How? Oh my god. They did something so stupid. And this is all over the place. Now that should work. Yes. Let's remove this print. And we are cruising. Instruction dot subtract. Put this in number 12. I'm gonna do two constant values. So constant value 1000, constant value 2. Let's see what would happen. 12 is going to be 998. Everything seems okay. So basically we have our basic instruction set completed. So let's not commit. Let's just add the root functionality, which is probably also present in standard library of Zig. Root std.math.square root. No rotation, no. I wanted to have, so I'm not gonna add root for now because I want to have this in a powerful way. So let's just commit this. So let's just git amend. I don't know. I didn't want this commit. Change last git commit message. It was wrong. Git dash dash amend dash m. Git dash dash amend dash m. Add all math instructions. Git, okay, git commit. Okay, cool. We got this. Let's see if everything is okay inside the git, and I'm gonna finish this video. We actually did a lot in this video. We basically implemented a small CPU that only works with registers and has all this functionality. Yes, if you take a look, we have all these functionalities, which is really nice. Yes, so that is it. If you like this content, like, subscribe, and follow, and if there's any problem, comment, Twitter, email, normal ways. I'm gonna continue this. I'm gonna do some research on memory stuff and then do the next video. Maybe this actually went too well. Maybe we can actually write this simple programming language that compiles itself down to this instruction we created. We of course we should add more how should I say this, more complete list of instructions, but for now I think it's okay. So like and subscribe, and until the next video, goodbye.